All right. Hello, everyone. Happy Friday. We have made it through another week. Get nice and comfy here. Get this dive on the road, so to speak. Get this dive in the ocean. We'll go with get this dive in the ocean. Let me shuffle a few more of these windows around. Did I click the go live? I think I did, right? Yes, okay, we're good on there. That looks like we're all good. And pause this and minimize. Let's close this. Let's close some more of these things that are open. It's not what we need. I didn't get my workspace set up beforehand today, unfortunately. Let's close a couple more of these. Okay. I think we are ready to get started. So hello to everyone. My name is Tim. I go by Foamy Guy on GitHub and Discord. This is the Deep Dive live stream program. This is a weekly program that occurs at this time on Fridays at, it's usually billed at 2 p.m. Pacific, or I guess is that 5 p.m. Eastern. It is 4 p.m. Central as well, which is the time zone that I am in. This program was originally started by Scott, the lead developer of CircuitPython. He has taken some time off because he recently had a child, and so his schedule got all changed around. I have been holding down the fort, so to speak, here on the Deep Dive. And yeah, this is the time that we do it. We're looking into all things CircuitPython. We're getting down into the weeds, in the nitty-gritty, getting our hands dirty with some code. Sometimes we're working in the core, sometimes we're working on libraries, sometimes we're working on projects, a mix of all kinds of different stuff, but the common theme that ties everything together is CircuitPython. If you are brand new, if you're watching this video in the future, if you haven't caught one of these streams before, and you don't know what CircuitPython is, a good place to start to learn more is circuitpython.org. This is the main website for the project. CircuitPython, though, is a version of Python that is designed to run on these tiny computers called microcontrollers. There's a bunch of pictures of them here on the downloads page at circuitpython.org. We are running Python on these little computers. We can plug it into the computer. It shows up like a thumb drive. We're able to write our Python code on there, save it on the device, and then it executes inside of the tiny computer. There are all different shapes and sizes. You can hook up all sorts of different hardware peripherals like, lights and buzzers and buttons and levers and beepers and knobs and sensors and, any kind of little electronic doodad you can think of. Screens, I don't know if I said, but all this kind of stuff you can connect up to these microcontrollers, these tiny computers, and then you can interact with all of these hardware peripherals from your Python code. So that is kind of the 50,000 foot view of what this is all about. If you are interested in contributing to the project, it is an open source project. All the development occurs out in the open on GitHub. We coordinate through the Discord, which is linked down below, adafru.it/discord. Is that right? Yeah, I think I said that right. It is down there on the screen either way, even if I got it wrong. There's a CircuitPython dev channel. All of the sort of collaboration and communication around the development takes place there. So if you're looking to get involved in an open source project, we'd love to have you come hang out in the Discord with us and get involved in this one. If you want to help support the project, but not necessarily by getting involved in development, another way that you can do that is just by purchasing hardware from Adafruit. This is their website, adafruit.com. They're a hardware and software company based out of New York. And Adafruit is the company that is primarily funding the CircuitPython project. So they pay the folks who work on the project full-time. They pay some other folks like me who work on the project part-time. They pay us to do the code, to review changes, to write libraries, to make projects, to make videos, guides, to live stream, to do all these sorts of things. Adafruit is paying the folks who are being paid to do this kind of stuff. So certainly thank you to them. And then, like I said, if you want to help support the project, you can do so by purchasing hardware from them. So go get yourself some goodies, find some fun toys to play with, and in doing so, help support Make Circuit Python. How's it going, C. Grover and DJ Devin? Happy Friday to both of you. Been up since last night working on the 3D modeling and printing. Might fall asleep. Adafruit microcontrollers. You said it great. You're doing a good job. Appreciate it. Thanks, my friend over there on YouTube. We have fun. So tonight, what I am looking at, more specifically, we're going to start out with some Ethernet testing, and then we're going to get into some gradients, presuming we have some time after that. So this will be not brand new to folks who have watched some of my streams before. I don't know if we did Ethernet. I don't think we did do Ethernet on Deep Dive, but a couple of, maybe a week or two back, I did some testing and reviewing of the Ethernet PR on stream. And so this is a new PR this time around, but we are getting back around to it because I noticed there was another new change in there. Sorry, I got to get the camera going here as well because we will have our own little microcontroller that we want to show. Something like this for now. And I have some extra hardware around, which we will potentially get into once we move on to the gradient stuff. But this is what we're using right now, a little Ethernet feather wing with a feather connected to it, which not connected to it right now, but about to plug in. I can keep it in camera. This in. Plug this into the computer. And I've got extra stuff on the desk today because one of the things that I'm planning on working on next involves some other hardware that I don't normally have out or have out on my desk. This is running the time puncher thing right now, but we are going to be switching out to some Ethernet code. I'm just going to leave it on this for the moment. We actually need to find our Ethernet code, so I'm going to go get the WizNet library opened up. Oh, I probably should have changed the batteries. My mouse batteries might be dying. We'll see if we make it. I've got some backup ones here anyway, so let's get to WizNet. Add typing, that's the branch we're on, but we actually want to be going GHPR list and GHPR. Oh, we're behind by 2 releases now. Goodness gracious. Are these still easy to install? Like, let's get this thing. Run it. Nope. Have officially become more difficult to install. It doesn't have an update button. And I guess I could uninstall and then reinstall, but then it might make me authenticate again. I don't want to mess with it right now. So we'll stick with the slightly out-of-date version for the moment. It was, I think, 80. Pull it up in here as well. So I am hopeful. I don't know if it's actually going to work out this way, but I'm hopeful that this PR might actually fix some of the weirdness we saw with my network. My DHCP, I think I was seeing some weirdness where I was getting back different IDs and it was making it fail. And this is talking about fixing a couple off by one, an off by one bug here, a logic bug here, another bug here. So I'm fingers crossed, maybe this might even solve some of the issues that I was seeing with my particular network. With I assume some kind of configuration or something about the way that my network returns the DHCP information was causing it not to work in my case. Except for the first time. The first time it joined, it was fine, but then if you restarted the microcontroller and it tried to rejoin the same network, it didn't succeed the next time. Go check out 80. If nothing else, it has better error handling and outputs, because that was the other thing, is one of the error handling things was like just printed a F. So that's one of the things I believe is in this as well. Take a quick peek through the code while we're here too. Magic cookie? Huh. I don't know about changing that. Interesting. These look like off by ones, I guess, here. A couple types changed. Response ID mismatch. This is the one I was getting, so fingers crossed maybe this will be resolved, but maybe not. Maybe it'll at least, I mean, if nothing else, it'll be a better error message, which is good. If we get lucky, maybe it'll be resolved. Check that there's a server. Oh, okay. Yeah, so there's a couple places where this was just returning 0, rather than raising like a coherent error. I know about magic cookie. That sounds pretty yummy. Whoa, 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 whoa. What's that? This logic actually changed a fair amount. What did he, now we have try except. Oh, I see. Okay, this is actually just try except on this line. Ah, the rare try except else. Or is... Is that right? I do think I learned about that. Is that a thing? Try except else? Execute if no exception. Do not see that one very much. I remember learning this and having my mind blown, kind of. Okay. T only. So the logic does not actually change too much. The print statement is a couple of lines longer, which makes it look more significantly different. Honestly, the biggest difference is the try catch on the bit up here. It's like error handling generally. Print error, if debug, transaction ID. There's this bit. Oh, no, but this is just, yeah, this is all just here, same stuff. Okay. +1. This is eerily similar to what I was getting when it was not working. I will freely admit I definitely do not know that much about the intricacies of DHCP. I'm probably not the person who could give a thorough review to this actual code change, but I can certainly try it out. PyTest. File renamed. I don't necessarily have, I mean, I kind of like the underscores, but it does make long names. I don't know. SDHCP. Oh, interesting. We would run this on the PC, maybe? Maybe we can run this as well. All right, give it a try. Let me catch up over here as well. First batch of cowbells went out yesterday. Be arriving either Monday or Tuesday. Nice. Depending on distance from Florida, got them out by Christmas. Sweet. Cowbell holiday carols can now happen. Tracks Updell is pretty handy. Occasionally overuse it. Yeah, I don't know that I have ever, I'm not sure I've ever used one. I've run across them a few times now, but that's about it. So we did check out, we're here, we're gonna take this over to our device. The lib folder here. I already have some stuff in here. This is MPY one. I think we can get rid of that. Gradients will be coming up once we get done with this. I'll play with gradients, or if the question is like, what do you mean by gradients? Then colors, like color shifting from one color to another. Yeah, there goes the mouse. LED colors display. Some of both, hopefully. Actually, yeah. Display, I've done some stuff with so far. And then LED colors, I would like to use the gradients that I've been working on with, and LED animations as well, actually. Which I will, if I pull the camera up just a tad. One of the things I have here is a LED strip of Neopixels to hopefully be putting some gradient colors into. Simple test we can go with. Yeah, I need to PR this. I keep saying this every time I've come back through this now. This one, it won't actually work with our device. All right, I feel like I check this every time, but I'm gonna do it again anyway. I believe this is the same as this. Yeah. How's it going, Kiyoshi? Happy Friday. Let's save that. Oh, I don't have open before. This is actually upside down. You could actually just flip it in the camera. How's it going, Beata? Have ants. Uh-oh. Deacon guest ants? Can I flip this? Auto reload. Look like it has an actual error, truthfully. Does Adafruit make nail clippers? I don't think so. You probably could not send me some either. Don't really get much better, do we? Did it run? What did it do? Right, of course. This is exactly what I was just talking about. So this won't actually work on my board because the SPI bus already initialized, because it is used for the display. Board.spy would be what we want. Nope, wrong way. We're upside down now. There we go. That one worked. We got the light though. Whoop, too far. Wait, this is upside down. I don't know. A bit tricky. All right, so first time through, it did work. And in fact, I want to say this was the IP that I got before. So I guess the real test for my network is going to be whether we can, like, just redo it and try it again. Well, we're also on an older one here. Mine actually succeeded twice, so that's actually good. I do think I maybe got 2 successes in a row in the past. I don't know that I did ever get 3 though, so I'm feeling pretty good. Even if we just got this far, even if we fail our request, honestly, getting connected to the network, getting an IP address, we were failing there on my network the way this was used to be working. Try accept is almost mandatory for working with requests. Yeah, the try accept for sure. The else bit is the bit that I don't see not quite as much. Failed to establish. So that's okay though. That's the request failing. Is actually also just what you're talking about, DJ. But yeah, see, that's just like networks are like that, right? Sometimes it's going to fail to fetch. That's just how that goes. So honestly, I do think this is actually seems to have fixed the issue with my network. We are on old CircuitPython 7.3.3. We will update that as well. Let's see. Super handy with requests because every API has their own failure message. You can catch each failure, do something different. Useful for hammering away until you start getting key value pair errors. Yeah. So this time we failed. We succeeded the first one, but we failed the Bitcoin one probably. Or I mean, it's timed out right now. It'll probably fail, but we'll see. Either way, it doesn't matter. Let's do update. Closed out circuitpython.org. -5. Oh, we don't actually need it to be upside down. The reason that it was upside down is because the timestamper draws it upside down, and because the display lives outside of the CircuitPython VM, it stays rotated. So we stayed rotated from like that. We stayed rotated from when the timestamper was running. But now that it will have actually reset and in fact gotten CircuitPython reinstalled on it, it will be back to normal, whatever the default orientation is, which is now going to be actually upside down to us. So we are actually going to need to switch it back around. On the upside, it actually moves in the way that my brain wants it to now. Failed to resolve hostname. That time it restarted itself somehow. Sweet. Oh. It was about to rerun itself, but I stopped it with Control-C. Let it go again. Timed out this one. Okay, yeah, like I said, the code honestly is a bit over my head. I don't know nearly enough about the specifics of DHCP to even really begin to say if anything is good or bad or wrong or right or anything else inside of here, truthfully. Functionally, though, it's looking good. It's looking better than the old one was, in my opinion, because it wasn't working reliably on my network. Unless if I did a static IP, or if I edited the driver to not care about the transaction ID, I think it was called, being different. Catching up on 2x about 15 minutes. Silly question, what's a state machine? Not a silly question at all. State machine is a programming concept. There's a very nice learn guide, in fact, that describes some of it. The way that I think of it, I'll link this learn guide as well, and then I'll tell you the way that I think of a state machine. The way that I think of it is a while loop, and inside the while loop, you have basically an if statement that says, if the current state is this, then do all of these things. Else, if the current state is this other state, then do all these things. Else, if the current state is whatever, then do all these other things. It's just a style of programming where you have a loop that's going around and around and around, infinite loop or whatever, really, really fast. And you have a high-level logic condition that says, if we're in this state, then this is the stuff we do, during this frame of execution. If we're in this other state, then here's the other stuff we do during that frame of execution. And so, like, as time goes on, user interacts with the program, things happen, and your program will just change the states. So, you could go from the loading state into the, menu state or something, for instance. Like, loading state shows a splash screen, menu state shows, a list of options that the user can pick from. And then maybe the user chooses a selection from the list and you move on to some other state, the sensor screen state or whatever. Like, just depends on whatever your program is. Yeah, I use state machines a lot with CircuitPython stuff. A couple of my guides are state machines. Yeah, I don't know, my friend. It doesn't seem particularly relevant. I would assume this is what saved us. Somehow I'm guessing these being off by 1 was what was leading to my transaction ID kind of being different. Ethernet featherwings are nice to have just in case something breaks again in the future. Breaks again in a future beta might be handy as a failover. They're faster, but sometimes you can't run Ethernet everywhere. Yeah, no, for sure. Ethernet's honestly kind of a pain to run to a lot of places. Yeah, anything outside or further away. I could see Whippersnapper being a great pair for always online logging, because all Wi-Fi drops off eventually. Yeah, for sure. Used finite state machine designs in hardware too. Great way to organize and manage sequential events. Hardware implementations exist in the core of the CPU chips. Yeah, I forget, I don't remember, was it Anecdata? I can't remember if it was Anecdata or maybe Neradoc, or I might even just be misremembering altogether. Somebody had one, though, where they connected, like, I want to say they had 3 different internet connections going on one thing. Ethernet, Wi-Fi, and then the cell data one, I think, was the 3. That going there. All right. Oh, beta 5. Beta 6. Uh-oh, beta 6. Don't have a beta 6 yet. I don't remember which... I don't remember which one of these was mine. $78. No? This doesn't get a response. Bye, my friend. Hope you enjoy your evening. Five is mine. I would guess some of these, I think it mentioned 79 as well. I think probably this gets better as well, but I'm not as familiar with this one. Yeah. Turn 0. Does not test for error. Yeah. Basically, this is where we ran into it. Our error was different, it looks like, than their error, maybe? Maybe not, actually. I think that was the same line. I don't know. Well, ours was less of an error. Ours was that this was not being equal. Our transaction ID was different. It was one number different, one number higher. $75 was mine. Okay. All right, I won't merge it for right now. We'll see if we can have, hopefully, maybe somebody who knows more about networking take a look over it, or at least have maybe a couple other people try it, because it does seem good in my environment. In fact, better than the old driver, because it actually works reliably over and over now without doing a static IP, which it didn't used to, so that's awesome. But maybe we can have some other folks try it. I know Anecdata is fairly active in network stuff and in this library, so maybe they'll give it a try, or maybe we can have some other folks. If anybody watching has Ethernet device and is interested in trying it out, definitely be appreciated. If you do, go ahead and leave a comment or leave a review on the old PR here, number 80 on the WizNet library. And then that's really it with Ethernet. Gradients are up next. So gradient, GitHub. I published yesterday this FoamyGuy CircuitPython gradient helper. This will generate a list of colors inside of a gradient. I heard a cat getting into something, but I don't know. I think Anecdata did 4 cutie pies from one outlet. I haven't seen the one you're talking about with 3 connections. Oh, yeah, there's definitely a cat getting into something. Use finite state. Oh, yeah, that's the hardware one. I'm trying to think if there's a good diagram somewhere for state machines other than the state. I mean, the State Machine Learn Guide has a diagram. I'm trying to remember if I've seen other learn guides with good ones. I don't feel like. I feel like I have, but I can't picture what it was. Okay. So where do we want to start with this? I think let's start with an easier Neopixel strip. I have this one, which has its own fancy printed thing. But it needs to be plugged into the device. Its device is much older. I'm going to want to update it when I get into it. So I think we are actually going to go back down just a hair. And I'm going to start with this one because this one is easier to connect. It's just plugged into the funhouse here. And what I want to do is generate a gradient, generate a list of colors, and then apply it to this Neopixel strip. I think should be pretty straightforward, honestly. But I haven't done it yet. I want to do it. Oof. Where's it twisted up there? Okay. And then I think when these lights turn on, you'll be able to see it. They're not facing the camera, but I think we'll be able to see it even if they're shining outwards. So absolute most basic, we're just going to go Neopixel library. So the most basic way we could use a gradient is just by setting the gradient, one color on each Neopixel. So that's what I'm going to do first. But afterwards, I want to try to work it in with LED animation. Because there's like Comet, there's a couple of them where they're single color. That'd be cool, I think, if they could be multicolor. They could be a gradient. And there are some that are rainbows. So there are some that are multicolors already. But I think it'll be fun to be able to define our own colors. Okay, I gotta check on this cat. What are we getting into, buddy? Okay. And ours is 30 and I want different stuff anyway. So we'll lift some of the code out of here, but I won't take the whole thing. This is a something group. Oh, we were okay. This was just testing the display IO API change. Whoops. Won't be this. It'll be the D0, D1, A0. I think this strip has 30. What is going on with the highlighting? I'm just gonna not do that. I think we'll try the default order and see what happens. We'll do a capital T. Ooh, there we go. I don't know if we need this. Like display IO, you need to do a while true, otherwise it won't keep showing. Oh. That's a bummer. Okay. First time I've done that though. Right, we're gonna take this. I'm just gonna go here for now. You'll swap-a-roni there. That. Okay. So, yes, we have red on the first pixel in the list. Neopixels basically just behave like a list. We have green on the last pixel in the list. And we must have 30 pixels. I must have got this right because first one is on one edge, last one is on the other edge. So nice. Let's get a copy of this. Don't necessarily need all three of these, but might as well try out each one maybe. Start with linear. Let's go pink to green. That was one of the examples on the page where I got most of this gradient logic. I've been redoing that. 10. We won't do 10. We'll do 30 because we'll do one per pixel. Eventually we'll make it work with different numbers as well. Can you do slices on Neopixels? Actually, no. You do like pixels, like 0 equals linear colors 0, 2? Don't have the library. Well, that's not true, I guess. If it works, it will work without the library too, but that in, whoops. Slices? Yeah, slices like a slice out of a list. So like if you have a list, for instance, you know, my list or whatever, like this, and it has 1, 2, 3, we'll just say 1, 2, 3, D, E, F, just to show that the types of the things don't matter at all, really. If you say, like, you know, ordinarily when you want to access things from this list, right, you go my list square brackets, you know, you'd say like 0, I want to get the first index, or I want to get the last index, let's say, or, you know, index number 3 or whatever. A slice is taking multiple parts from the list, so you could say my list, like 1:3. This will give you what they call a slice out of the list. It will give you the items starting at index 1, going to index 3, but it's, I think, exclusive. Yeah, it's exclusive on the right side, but inclusive on the left side. I don't know why, just how it is. So like index 1 does get included. That's the 2. Index 2, which is actually the 3, somewhat confusingly, sorry about that, does also get included. Index 3, which is the D, does not get included because that's exclusive on that side. But this allows you to take a section out of a list, or if it's hooked up, then it may allow us to actually put a section into a list as well. However, that part, I don't know if this will work, although it's pretty good to me. So is there one of these? There is, isn't there? Isn't there a slice for all? Is that just colon? I feel like we just came across that sometime. Yes. So seems promising, right? No? Oh, we're in REPL. Okay. Nice. Cool. It gets closer to white over here. I mean, I don't think these colors probably aren't going to come through. Maybe if we do this better. I need to think of slices like ranges with start stops. That's true. Yeah, like range, like for I in range, which also is the same where it's exclusive on one side. And actually, I forgot. You can, I think you can do steps in slices? I don't remember, actually. Now that I say it, for a second I was going to say... Yeah, you can. You can do step as well. You're trying to get evens or odds or every fourth or whatever. One thing we could do to get further away from white in the middle here, could we just make these overall darker? Is that gonna get us farther away from white? A little bit dimmer. Dimmer. That shows the color a bit better. Okay. Okay, so that's pretty cool. I do like that. That is a fun utility, a fun thing to be able to do. Let's do one of the fancier gradients as well. We'll pick some new colors. What do we think for colors here? Let's use a blue. Let's go blue to yellow. I don't know why I'm doing uppercase and lowercase mixing. Let's go all lowercase. Purple. Down with purple. So we go blue to yellow. We go purple after that, or do we want to try 4? 4 might be a bit much for this strip. I think the strip that's on this heart shape is a bigger strip. I think it has more pixels in it, so we could do bigger. We could do more colors on that one and have it actually turn out better, I think. Mixing is for chaos hours. Case mixing is for chaos hours. Blue to yellow. Well, so purple is tough, actually. I'll need a eyedropper or something to get purple. I don't know a purple hex off the top of my head. Only pink. Purple maybe, I don't know, it may look more pink when it's on the actual LEDs, honestly. But that's the hashtag kind. That looks like. We'll go numpixels. Go this. Purple is on the far end. It's very bright. Did come out more closer to pink, I think. Not sure about the yellow. The yellow seems basically just white. I guess that kind of makes sense, though. If you gradient blue to yellow, you already have max blue and you're approaching max. Maybe we don't want blue to yellow. You don't actually really see the yellow. Kind of just looks like blue to white and then white to purple. Now we can kind of see purple, like blue to purple to yellow. And I do actually like, I will say I like this transition from blue to purple here. Doesn't come through the camera quite as well. Like through the camera, it looks a little bit closer to white, I think, but to the naked eye, honestly, it looks further into the purples there, whereas like this bit over here looks a lot more white on this side. Okay, so that is actually super easy because of the way that pixels already behave like a list and we are basically making a list of colors. Super easy setting it into there, no problem. I was thinking I hadn't really thought through how it was going to work. I had no idea it was going to be that easy. That is actually super easy. Catching up, two Ethernets, 2 Wi-Fis, there we go. Anecdata linked the gist from the Mega Internet of Doom device. You have a definition somewhere for how many pixels should be the color. Does look better. Do you have diffusion plastic? I do not have diffusion plastic, unfortunately. I have sheets of white paper, which sometimes make it look better. But right now, the sheet of white paper that I have that's closest is actually underneath this, and there's a lot of stuff on top of it. I don't know that I can shuffle it out of there. I don't know if it's going to make it too much better, even if I can. Probably won't be able to get things back. Yeah, I think our problem with that is that our lights are also not pointed straight up into the camera. Since they're pointed outwards, the paper diffuses it almost too much. I am also on like low brightness too, though. I could probably crank the brightness, but be all right with this for now. Okay, let's try this bigger one. Try the bigger one. Dropping the overall brightness can help. I am on 0.1. I could still back off a bit, but I am fairly low already. It does actually help it come through the camera quite a bit better. Top with cranked brightness, yeah, that's probably how we'd have to do it. Piece of paper. Cut straight and long, yeah. I think it's, if I had them pointed up, I think it would, the paper would be good, but I am gonna see, oh, did I? So there's actually a bit of a mystery on this device as well, this one with the heart. Maybe we'll get into troubleshooting that some. I don't know, the first thing I want to do is certainly try out the gradients with it, but if I recall right, this is doing a thing where some of the LEDs actually are a color that I don't know why they are the color they are. We have a bit of a mystery. All right, let's get this out of here. I will turn the main light back on. And so one thing is, I noticed this came unplugged when I took it out of its home, because it is a very precarious breadboard wired thing here. I'm scared to even move it all up in the camera frame, because the wires aren't that long and they come unplugged very easily, so the circuit's not that interesting anyway. I promise. It's power, it's ground, it's data. Right now, ground is plugged in. That is it. I need to figure out which one is power. Power is this outside edge right here. Power, I guess we're probably going to be wanting the 5-volt power for Neopixels, which on this feather is labeled USB. Then data, I have no idea which pin the program is written for. We're going to plug the device in first, and this device is probably going to be on some kind of ancient CircuitPython. I don't even know. Oh, yeah. Well, no, that's our data pin. I don't even know. I do not even have any idea. I wonder this is gonna be. Fresh. Oh. 700 Alpha 5. Not actually as old as I expected, to be honest. still a ways back for. This is a Feather M4. So from 700 Alpha 5 up to 800 Beta 5. We'll make the complete jump. How's it going, Deshipu? Was on a 7 Alpha 5 board. Uh-oh. On the same one, having trouble, huh? Hopefully we'll be... You know, if we get lucky, honestly, I'll upgrade this and then we just won't have that weirdness with the color. Should we let it... Let's let it run once, actually. Let me let it run once. Before we update it, pin D9. This one has 96 pixels on it. Pin D9 is where we want to plug this in. Mine is probably just 9. Okay. Pin 9, plugged in. Back to light show mode, maybe? Really, the main thing I needed the light for was to get those breadboard wires plugged back in. Okay, so I think it's a pretty short little cycle of things here. We'll let it run through its thing. This one's rainbow. This one, as far as I know, everything seems fine. So you see this? There's a red one down here in the very bottom. So this one seems mostly fine. Red and white, red and white. It doesn't really come through very well, but this one down here, the first one on this side, it's turning red sometimes when it's not supposed to. This is where it's most apparent. I believe this is supposed to be all blue, but we have that red down there. And if you once you see it in that one, if you start looking for it, you start to notice it in other ones as well, where this, basically like this last pixel here, sometimes is just red when it's not, doesn't seem like it's supposed to be. How's it going, Axel? We are working on some gradient fun right now. We're trying to figure out how to apply gradients to Neopixel strips, or I should say we did figure it out. It's super easy, actually, since both behave like lists. The slices make it super easy to set our gradients into the Neopixel. So now I've got this thing out, and I'm about to update it to a new version of CircuitPython, and we're going to apply some gradients onto it. Ultimately, I'd like to try and hook it up so some of these LED animations can use gradients as well. Right now, I have a couple stock LED animations running, but I'd love to make them to where they can transition through the gradient of colors. Like, you know, imagine this if it was like blue on this end and it transitioned to green as it made it to the other end or whatever. I think some stuff like that would be cool if we could apply those gradients to the animations. Some of them have rainbows already, but I think it'd be cool to be able to just pick and choose which colors we actually want beyond only the rainbow or any of the ones that are built in if there's others, I don't know. But first thing we need to do is get this updated. Actually, I will need this light back on because I cannot see the reset button. And then we might indulge a slight rabbit hole, you know, if you will, go down the rabbit hole a bit. We might indulge a rabbit hole of why is this 1 pixel red when none of the code tells it to be, as far as I can tell. We'll see if it's still doing that after I update it. If it is, and we play with our gradients a little bit, then that'll be the next thing I do, is a bit of sleuthing, trying to figure out why that pixel is getting painted red sometimes. Which is unrelated to the gradients altogether, but I just happen to know that this thing does that, and It's been on my list of stuff to look into for a while, and I haven't done it because this thing ordinarily is just mounted to a wall somewhere else in my house, and so I don't take it down very often. But I have, so now is the time to work on it. Where am I going? I do not even know. Let's copy this from here and then go to the boot drive. Supposed to be going at least. Okay. Go back to Brave mode here. Oh, yep, it's fixed. Red one's gone. So that was easy. That will not require any sleuthing. Does look a little red here, but that might be intended. This one is kind of like red to pink to blue. This one is rainbowy, so like occasionally it'll be red here, but it was red more often. This one is red because it's just resetting. This is just the reverse of the last one, so it's also red because it's resetting. This one just has red down here, so that's fine. The blue one where it sends like one thing around, that's the one where it was most obvious. This one a little bit, and I don't see it there now, so we're looking good. Let's get the blue one though. Not this one. Although I don't see it here, so that one's looking good too. I think it's next maybe? Nope. After this one? There we go. Yeah. This one was the most obvious. There was red down here, super clearly red. And now we don't have any, so sweet. It's fixed. No more phantom red. Let's do some gradients. This is the code that's on it. The code that's here is going to be super basic. It's just initializing the Neopixels, setting up LED animations on a, what do they call that? A sequence, I think? Sequence of animations? Yeah, animation sequence. And then just running them automatically on a loop there. Chase. No. Which one is the single blue? Comet, it must be. Well, but that says tail length 20? I don't know. All right, here's what we're gonna do though. We're gonna take this. Just save that as a backup. And then I'm gonna get rid of everything after we set up the Neopixel. Strip all the Neopixels. And then our other gradient's actually on the other device. Could plug back in, but I think I'm just gonna steal from. To put this on the device also. I think it's, oh, it did actually find it there. Interesting. Okay. What happens if you do a 2-color one of these? I don't know if I ever tested that. I'm gonna try a 2-color one. So now this is what we just discovered on the other list, is because of slices, you can super easily just go set all the pixels to all the colors in the gradient. Now you It would be a bit more complicated if you didn't generate... What is going on? Oh, right. It'd be a bit more complicated if you did not generate the exact number of colors you needed. Maybe we'll do that next. So we have 96 pixels. We're generating 96 colors. We're about to. But what if we only generated 30 colors? We could still use map range to actually set it accordingly. Oh, interesting. Okay. Wait. Did that work? I'm not sure if we're looking at just where we happen to stop, or if this is actually what it looks like. Is this actually what it looks like? Maybe that's actually what it looks like. Oh, I don't know. No, something's broken. It's not filling. Yeah. There we go. Okay, that's what it looks like. That makes more sense. Yeah, no green. We shouldn't have the green in there. There's our yellow to blue. And it is white in the middle. And it is also ultra bright. Let me chunk that down. Saw that came through quite a bit better. So in this case, it's not that much better, is it? This one has its own diffusion, but it does, it throws it off a bit in terms of getting picked up by the camera. Blue to green. If we go blue to green through red, it's probably going to get us pretty close to white, isn't it? Kinda, but not actually. Almost like blue to pink, and then pink to orangish to yellowish to green. That's kind of a cool one. Okay, so that's pretty sweet. We can set our gradients on here, and this, I will say, like, it doesn't look that cool through the camera. Honestly, obviously it looks way more impressive to the naked eye than the camera can make it look. This one is not great for picking up this like sort of neon strip or whatever. These ones are facing upwards at the camera, and I think it's just washing it out. I don't know if we got even dimmer, is that gonna help or is that gonna hurt? I don't even know if they'll run that low. Oh, interesting. Huh. You can kind of see it, but the colors still are washed out a bit, honestly. Yeah. It's looking pretty nice straight to the eye, though. And this strip is a lot more suited to showing the whole gradient like this because it's got so many more pixels in it than 30. We have much like really, really smooth changes in between all of the colors here. Point 2 looked patchy. Yeah, one of them they didn't, it turned some of them off. Like it was almost like not enough power to even light some up or something. Interesting. One day some company will produce cameras that can show LEDs accurately. Oh, yeah. They'll make a fortune from YouTubers and makers, yeah. Okay. Can you rotate a list like, so like if I have a list, right? Is there a thing I can do? Is there like a function or something I can pass this to or call on it or whatever to get this one? Like starting at here and then like afterwards, you know, get the next one, like just kind of cycle through it like this, and they just each time you advance forward by one and the beginning wraps around to the end. Because if we could do that, we could like rotate this around the whole strip so that like right now blue is here and green is here. If we could do this like rotation thing here, we could kind of spin it around. Use a -1 step, can pop from the end and insert at 0. There we go, pop from the end, insert at 0. Yeah, thank you. I was not thinking of it that way, but that's exactly what we want. Or other way around, pop from the beginning and add to the end is basically what we want. But yeah, okay. How do you do that? So pop is going to be the end, I think. Oh, right. This is actually still this list here. Yeah, pop is the end. Is there can you pop an index? Hey, whoa. Index. Can we do that here? Yeah. Okay, sweet. So we could go, so inside our for loop, we go, I mean, inside our while loop, I was going to say we make a for loop. We don't even really need a for loop, though, truthfully. We could just do it in here. So let's go Bessier colors. We're going to append a new one on the end. The one we're going to append on the end is the one we got from the beginning, which is pop 0. So grab it from the beginning, remove it, move it all the way back to the end, and put it back on. So we're going to do that, and then we're going to update the pixels by just doing this again. Probably we're going to want a little bit of sleep in here, otherwise it might go crazy on us. Maybe something like that. I don't know, is this better? Is 5 better? Hoping we get a setting if we can land on where the colors will come through a tad better. I don't know if we're gonna get that lucky though. Yeah. That's actually quite slow. We might have gotten away without this. Yeah, I mean, that's about the speed the animations were running. It's too bright. This one might benefit. This one probably would benefit from the paper. Unfortunately, though, my paper is not actually big enough to go all the way across, so even if that would work, it's not gonna help us for now. Okay, that's fun. That's a neat kind of animation. A rotating gradient animation, maybe. So like, what would be a fun exercise maybe is adding a new animation object. Is slow because you're copying? I mean, I feel like it's pretty fast, honestly. This one without this is, I think, about as fast as the what you call it? The animations I had running. In fact, this might be a bit faster. I mean, I'm sure it could be more efficient than this. What, we could just always change. I mean, we could always, I mean, I guess we don't even, do we need to actually change this? I suppose we could just not even update this and only do this one. So this is like, don't care about efficiency, just want the easiest code, but we could actually go pixels. So we go, let's go temp equals none. Let's go temp equals. No, we can't do that. Every index needs to change. I was going to say we only need to change the first and last one, but that's not true, though. We actually would need to change all the rest of them as well. I don't know. Is it going to get more efficient if because we still have to change, basically, every single pixel has to change to whatever the color its neighbor had last frame. So, I mean, I have no idea if, like, maybe using a for loop instead of this would be more efficient. I don't know. That could be. But I think, I mean, I wouldn't suspect by that much, would it be? Efficient way to do it is use a ring buffer. I will freely admit I am not up on that. I'd have to read into that a bit. Change the color list to start and stop with the same color. That's fun to me. I like it. Let's do it. So now we always have the same. Now it, like, both ends are always the same. Beginning and the end of the strip, which are down here, are always the same now. We did get a bit closer to white in some sections as well. Okay, I want to look at Comet, I think. Oh. I think that Comet was the one we had before that was just blue. Had a tail length of 20. Hey. Come on, buddy. Little fuzzy dude, always getting into things. Okay. So we would basically, instead of these, we would go comet.animate. Comet has only one M. Alright, there's our comet. I am surprised. I think our thing said 20 on the tail length. It's awfully large. What it actually does. Speaking of awfully large. For you, my dude. Hey. Okay. Tail length 20. I feel like it's small. It does go way faster. Speed 1. Okay, I guess that's about what it looks like. We have bounced false on that one, but it doesn't matter too much. Okay, let's look inside comment and see if we can already, maybe we can already give it a list. I actually don't know how it works at all. What I would like though is if we could give it a list instead of a color, and if like each time it updates, it will also advance through the list of colors. Does look like so. It looks like so far it's written for a single color. It does have comic colors though. Computed color. Set color. Self comic colors equals black. Interesting. Length, comic colors append, calculate intensity. So this is, I see, okay. So one thing it does is it makes a tail for the comet, which kind of fades out towards black from whatever color. So in our case, blue. Whether it's reversed, ring, raw. Object, number pixels is length. If ring, there's pixels. This one has colors here. Start equals colors. Start +1. Start wraps around here with the if statement. Else if it's not ring, then it just goes color and colors. Break. Pixels start equals color. Else equals 1. How would we do that? Set color. Computed color. Curious what we have for comet colors here. Is that... Curious what we have for that. Is that a list representing individual pixels and the color that they have right now? Or is that a list representing... like this is one color, this is a little bit darker, this is a little bit darker, this is a little bit darker, without regards to how many actual pixels are colored that color. I could see either, but I don't actually know. You keep it, let's see, you could keep the list as is and only increment the index and then do pixels index : equals SEA colors : total minus index. And swap around. You make it a memory view? I haven't used memory views before either. I'll have to look into that as well. It's basically a list of hexes though. If that can make it behave as a memory view, that'd be pretty sweet. Kind of use like the before slice and the after slice. Increment the index. Is it less operations? Is it just splitting in half? I'd have to actually try it, truthfully. Can't quite picture what it's doing in terms of how it's gonna slice. Let's clone. You actually. You have the same number of pixel update operations, but you don't have the cost of I see. Okay. So the actual pop and append functions. Right. Is your I see. So you, instead of pop one side and append the other side, you're always just keeping track of the current index, doing everything before and doing everything after. So the actual order of the colors in the list doesn't change in that case. You only update the neopixels. In fact, yeah, you just update the neopixels. You don't change the list of colors at all. Okay, that does make sense. Yeah, because it wouldn't. And then yeah, I guess it also would make sense. These, I have no idea what the tax is, but yeah, the tax inside of append and pop. Where's the rest of this? Actually, right branch. Oh, they were there. We might as well, I guess, put the new one though. I have no idea how old the version I had was. Pop is ON because it has to move all the elements. Okay, so I am interested to see inside of here what is this list. Probably gonna spam really fast. Did spam really fast, but then it stopped. So this is basically from black to the color that was chosen. $11. We gave it a tail length of 10. So will the biggest one be 6 this time? Okay, yeah. So this is generating... Although this doesn't go all the way to blue, interestingly. The last one go all the way to blue? I thought it did. No, actually it didn't. Okay, it just only went to 230. So this is basically generating a list of tail length +1 colors that go from black to the color we specified. So it's basically able to... It's kind of already doing a gradient, but it's just always doing a gradient from black to your color, or vice versa if you want to think about it the other way around. So what if we had gradient comet, or we forget to do this, we make this do this first actually. Gradient comet here. This will, so far, should still be the same. Should hopefully work. Import comet. Keep comet? Would we not be able to import comet? Oh, so I changed the wrong one. It's not even really a gradient. I don't know. We'll change the name of it later. And there's a couple of ways this could work. To start with, I'm going to try to make it so that instead of this thing generating its own list of colors here, I want to try to make it so the user could pass this in. How does this actually get set up? Could look at comet colors and maybe computed. Well, computed color is a single one. We should maybe look at comet colors also. Left side, right side, ring, super initialize, reset. Who calls this? Oh. I guess. Called after a color is changed. So then color to get called the first time. Right here. Triggers set color, yeah. What's our computed color after we get those? All the way blue. Which is, I guess, really just the same thing that got passed into us, probably, right? Same thing that got passed as this. I don't really know why it's getting set again back here. It's already set there. I don't think this is actually changing it, but I'm not sure. So let's go self tail colors is equal to tail colors, and then in here let's go if self tail colors do this stuff, else do this old stuff here. Then in here we're just gonna go self comet colors equals self tail colors. If we don't update our signature when we call it, nothing changes. Why don't we go back to the gradient every time? Do I still have gradient in here? Ah, right, yeah, okay. Fair enough. Let's do that. Okay. So far we haven't changed it, but now if we go tail colors, near colors, our thing was our tail size +1, so for now I'll keep this equal and do this as 11. Expected argument. Did I not add it? I did. Tail colors. Expected argument. Underscore. Ooh, okay, interesting. So we have a comet going around, but our comet is red and our everything else is green. We're not getting black. Guess we actually still need black. So let's say this is... Whoa, 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 whoa. Whoa. Do 10. Near colors. Near colors, insert. 0. Black. Our comet just had black at the first one. Yeah, that's what I was trying to get. Sweet. So now we have a comet that follows a gradient. You can tell it which colors you want your comet to be. And instead of fading to black, it fades from one color to another. Or if you wanted, you could do a triple gradient and one of them could be black. In fact, instead of inserting black, let's do this differently. Let's make a new Bessier comet colors. Let's go, oh, do we want to go from black? Maybe we want to prepend the black. Maybe that's the better way to do it. Let's try it this way though. Let's see what happens. So let's go from black to green. Or should we choose new ones? Let's go from black to blue. To red. Let's try like that. I don't know what that's gonna do. We'll do 10 though. 11 actually, if black is part of it. Interesting. Slow it down some. If we do it that way, we don't actually have to include the black at the beginning. Although if we actually make this into a shareable class, it's probably better to prepend the black at the beginning. That way the user doesn't have to pass one that contains black. So what would we do if they didn't fit perfectly? Because I think this now is just basically ignoring the tail length. Like, I think this actually just looks the same as it did before. And now if I change this one to be 21, now I think it will be longer. Yeah. So we actually will want... Ideally, we would want... No matter how many colors they pass in, we will want to generate that list using map range comparing to how long the tail is. Which means we get a little bit more complex in here. We can't just set this to this. Instead, we're actually doing something kind of like this. I'll just leave the black here. That way we're appending it. And then in here, we're going to be looping this many times. Gonna do intensity, anything. Are gonna append a color. The color we're gonna append, though, that's gonna come from tail colors. The index we're gonna get is gonna come from map range. Int work again. In minimum, in maximum. So it's gonna come in as this, which is the minimum is 0, the maximum is tail length -1. Oh, I did it wrong. It's in min. No, I didn't. Yeah, I did it right. In min and then in max. Out min, out max. Oh, and then number is actually first, so we should do in over here. In min, in max, then out min, out max. So this will be 0 here, and then it will be length of the tail colors. So this will basically map the difference between the length of tail colors versus the length of tail length. So then I think this one will give us the long tail again if we set this to 20 but still have this on shorter, like 11. No module, simple IO. Got a date circup also. X out of range. Off by 1 error, or do we have like completely way off the mark, not even close error. Color index 11. Yeah, which doesn't exist because this is 11 long. So out max is too big. Should be -1. Are there any use cases where background isn't black? Background isn't black. I'm not sure what you mean. You mean the comet specifically? I will say the black seems important for making it actually turn off the part where the comet is not. If you don't use black as one of your colors, then like over here would not be off when the comet is over here, for instance. I do think this worked. So now we have only 11 colors. Our tail length is 20, but we do have the long tail. We could even further go like 5 colors. We still get roughly the same gradient. So now we can independently change the tail length from the colors. Actually, we could get rid of this. We already do have black getting added in. Yellow. So one thing is I don't know if the tail length is shorter than the colors. Still does work pretty well though. Got green to yellow. Okay, that's pretty cool. I do like that. Okay. That's cool. I don't think it's ready to share yet. I think there's still some work to do on it, but I think the basic idea, this is pretty similar to what I was going for. I wanted the way to be able to like make the comet be your own colors rather than just a single color. So now we have yellow and green. You can do any colors you want in here. You could do more than 2 if you want. You can have 3 or 4 or however many. And using this new gradient comet, which we'll probably rename that to colored comet, maybe. We have custom color chase, so maybe custom color comet would make sense. Probably would make sense. Something like that. Because it wouldn't have to be a gradient either, right? You can just give it 2 colors, 5 colors. You can just make up the colors you want. They don't have to actually be a gradient. Can be any colors, obviously, just a list of colors, which is exactly what our gradient functions return. So that's what I'm using with it, but obviously it could be anything. I have 11 of the Neopixel BFF. What should I do with them? I realize making a 5x5 pixel game is kind of beyond my scope right now. For example, if you wanted a gradient bluish comet traveling around a solid red heart. Oh, okay. Yeah, in that case you can, well, so I will say that one, in order to make that one work, you would have to not set black in here. This is probably not the best name for this, but empty list. Okay, so right now the behavior doesn't change, of course, because we didn't change that thing to true. Let's go back to 20 here. Let's go, you said what now? You said bluish? Having around a solid red heart. We're gonna have to be making a guess on which one goes first and which one goes second, because I do not remember. Oh, we still have black, actually. Oh, I didn't pass it still. I didn't pass it still. Duh. Use black now. Use black. Crashed? I put it in here. Right, also that shouldn't be, that should be this, use this, and then up here. True. Okay. Bluish comet traveling around a solid red heart. Nope, we were backwards. Oops. Ooh. All right, there we go. Solid red heart with the blue comet flying around it. And then it turns out that you get a tail of kind of pink because it fades from the blue into the red, which of course goes through pink. So in order for that to work, you do have to basically, you have to instruct it somehow here not to start with black. So we would either have to like get rid of this altogether and not have it just assume that it's going to put black, or we'd have to do something like I did here with a Boolean, one of the two. If we just got rid of it altogether, then the user could always use, like the user could always put black in their list. But I think it's probably good since the regular comet does it by default, I think it's probably good for this one to do it as well. But maybe we keep the Boolean like this. That way you can switch it into this mode where you don't have a, you don't have like a darkness portion of the thing. You have everything is always on, and it just gradients from on to, like from one end to the other of your colors, essentially. Sweet. All right. So that's awesome. I am happy with the progress on that. Like I said, I don't think it's really ready to share yet. I do think there's still some tweaks I want to do to it. I'm sure the name, probably Gradient Comet, is not really what we want to call it. Of course, I've been using it to test the gradients, but the truth is it could be any list of colors, right? It's really just a custom color comet. So I'll probably change the name up and get the code cleaned up, get things fixed up, get it actually documented properly. And then once all that's done, we can actually make a PR from it, get it submitted to LED Animation. I think that's going to do it for tonight, though. That is the main thing that I wanted to play with, was gradients and Neopixels. And I would say we definitely achieved that. We figured out how to set a list of colors into our Neopixels, so that way we can just gradient across the entire strip. We also figured out how we can animate that by popping from one end depending on the other. And then here we have now figured out how we can modify some of the LED animations to start using our lists of colors. I think there will probably be a lot of stuff if we look inside of these rainbow, like Rainbow Chase, Rainbow Comet, Rainbow Sparkle. In fact, I should have probably looked at Rainbow Comet. I didn't. This is the one that's going to be having some different logic inside here where it's doing color wheel. But I suspect we could pretty easily adapt the rainbow ones to use gradients instead of rainbows, because right now they essentially have a gradient. It's just all the way through the whole rainbow. So we could just give them a different gradient that's only through certain colors. And I'm pretty sure all 3 of these will be easily adaptable to do that. So that's what we have to look forward to next. Thank you, everybody, for hanging out this evening. I do hope everybody has a good Friday evening and a good rest of your weekend. I'll be back on my own stream tomorrow morning at 10 a.m. Central Time. So if you're interested in that, you can come out to the same Discord. I'll post the links in there when I get started. Beyond that, though, thanks for hanging out, everybody. Thanks for the questions, the comments, everything else. Appreciate everybody watching along. I hope everyone has a good evening, and I will see you all next time. Good night.